So today we'll be solving quadratic equations. You notice the degree of this of quadratics is 2. So looking at stuff that has x squared in there. This is the engine that drives some of our factoring that we do. We don't have to, you don't have to write this down necessarily, but just know that when you have two factors, like we're just call them A and B, multiplied by each other, we want to set them equal to 0. The reason for that is because if they're set equal to 0, then you know that either A equals 0 or B equals 0 or both equal 0 in order for that equation to be true. So that's why it's really important in factoring. The first step we do is, if the equation is not set equal to 0, set the equation equal to 0. Like this one's already set equal to 0. That's beautiful. That's going to help us so that when we do end up solving this one, because we're to factor. So today we're going to go maybe a step further than we've gone before with quadratics. Although I think you've probably done this before. So it looks like 2 and 3, maybe plus and plus. And so for this one, because I know that either, this parentheses equals 0, so you can actually set it equal to 0. X plus 2 equals 0. Solve it. You get x equals negative 2. That's one of our solutions there. And then essentially you're doing the same thing for the other parentheses. One of the parentheses or both of them equals 0 because they multiply to make 0. So you set that one. And a lot of times you can do this in your head. Like a lot of students will just go, oh, that's x equals negative 3. That's the value that if you plugged in a negative 3 right there, negative 3 plus 3 is 0, and you just know it, right? So when it's an easy one like that, sometimes they don't show their work. Sometimes it's a tougher factor, and it's better to show the work there. So here are the 3 steps. Set the equation equal to 0. That's important because that's how it works. Factor it if you can. Set each factor equal to 0 to find the solutions. So if you have something like this, the first thing you want to do is set that thing equal to 0. So we're going to subtract x from both sides and subtract 3 from both sides. I'll just do 2 steps through one. And so you get on the left-hand side 4x squared minus x minus 3 equals 0. You're going to try to factor that. You might have to use the AC method if you can't guess and check it. One of these is going to be x. One is going to be 4x maybe. I don't know. I guess I should have started with 3 and 1. Let me just see if this works. I was thinking that 4 and 3 could add up to negative 1 if the 4 was negative plus, let's double check that, negative 4 plus 3 is negative 1. Negative 1 times 3 is negative 3. That works. And this, you set that factor equals 0, you get x equals 1. This one you might actually have to set it equals 0 to show your work because it's harder to do in your head. Some students can though. So you get 4x equals negative 3 divided by 4 divided by 4. Get x equals negative 3/4. So you get 2 solutions, net 1 and negative 3/4. And just to help you see like visually what's happening here. So let's solve this and then we'll graph it just so you get a sense of what's happening. And this is an easy one to factor here. A lot easier than the last one. 3 and 1. See positive, negative. So x equals 1, x equals negative 3. So these are the values where x is a solution on the graph. So on the x-axis, I know it's going to cross at 1. And now it's going to cross at negative 3. So I know those two pieces of the graph. By the way, what's in standard form here, this is the y-intercept. So I know the y-intercept is negative 3 right there. So I know the x-intercepts and the y-intercepts pretty quickly here. I know this is a very symmetric graph. And what I mean by that, if those are the two solutions, this is going to be kind of a U-shaped graph, kind of a parabola here, if you've seen a parabola before. And so I know that this is very, very symmetric. So that's the axis of symmetry. If there's a point kind of just 1 unit to the right here from there, there's got to be a point right there. It's very just like there's a point 2 units to the right there. We could find the value of, let's see, if we plugged in that value of negative 1, let's plug in negative 1. So that'd be negative 1 squared plus 2 times negative 1 minus 3. That would be 1 minus 2 minus 3. That's negative 4. So negative 1, negative 1, 2, 3, 4, negative 1, negative 4. That's going to be the vertex of this parabola. And I know I don't expect you to be able to graph this yet. but I want you to see the graph and just kind of see. So it's a parabola, and it looks like it crosses the x-axis in two spots, has two solutions. That's not always going to happen, though. What I mean by that is sometimes there's a couple other scenarios. So there's really just three scenarios that can happen with a parabola. So one is, like just we had, your solutions are where it crosses the x-axis. It has two solutions. So this might be what we call a two-solution parabola. Sometimes the parabola comes up and just, comes up or down and just barely touches, just nicks it right there. And that would be a one solution, quadratic. And sometimes parabola does something more like this, and it doesn't actually touch the x-axis. So we would say there is no, clarify, I would say there's no real solutions. Sometimes we just say no solutions, but there technically are some imaginary solutions, but it doesn't seem to cross the x-axis at all. So those are the three situations you have with quadratics. I think typically a lot of them are going to have two solutions. That's what you normally expect, but sometimes you run across some of the others there. So keep that in mind. Okay, so going back to what we did a couple days ago, so or maybe just yesterday, I'm not sure, it depends on what class you're in, but if you can get to this point in solving a problem where you have like x plus or minus some number squared, I hope you know these steps by heart. And what I mean by that is I hope this isn't too hard for you to go, oh, square root of both sides, remember the square root principle, we talked about it. It'd be x plus 1 equals plus or minus 2, subtract 1, you get x equals negative 1 plus or minus 2, which is really two different answers. Negative 1 plus 2, which is 1, and negative 1 minus 2, which is negative 3. And so I get two solutions. This is a quadratic that has two solutions. We just talked about how many solutions it might have. But I hope that's relatively easy for you. So that's the goal. And when I say it look like that, I want it to be like x plus something or minus some number squared equals some number. So I want it kind of that form, either plus or minus there. It doesn't really matter. But if we get it to that form, we could just square root both sides, solve the rest of it. That's kind of the goal of completing the square. So this is called a perfect square binomial, I guess, or perfect square. When you multiply it out, it's a perfect square trinomial. So you want to get these perfect squares. So to get that, I want you to see kind of some math of this. So I'm going to show you just a little bit here. So there's a calculator command called expand. And so I'm going to expand x plus 1 squared. So if I FOIL x plus 1 times x plus 1, you might even be able to do that in your head. It's x squared plus 2x plus 1. If I do, let's see, x plus 2, I want you to start seeing a pattern squared. X plus 2, so x plus 2 times x plus 2 is x squared plus 4x plus 4. Just going to copy and paste that and change that. Whoops. So let me just see, that was 2. And let's make this one 3. Let's make this one 4. You might even be able to start predicting. Now maybe you see a pattern. Do you see the pattern there? All those are perfect square binomials, perfect square trinomials when you multiply them out. And x squared plus 6x plus 9, x squared plus 8x plus 16. Could you almost predict what x plus 5 times x plus 5 would be? I bet you could. Right? So let's think about that for a second. So x squared plus 10x plus 25. In other words, I imagine that, we'll come back to this in just a second. I imagine that some of you, if I said the next one was x squared plus, well, let's say it's this, plus 14x plus blank. What would be the perfect square? Make that a perfect square trinomial. If you look at the pattern there, may not be obvious. It looks like I'm guessing this is going to be 49. Because if you kind of take the half of this number is 7 and you square it, you kind of get 49. If I told you, I don't tell you the middle term, but I told you this is 81. Do you have a guess what this middle term would be if it's a perfect square trinomial? So let's see, that's 81. Square root of that is 9. 9 times 2 is 18. I think it would be 18x. So if you see that pattern I'm talking about, That's the pattern we're trying to get, because we're trying to get something that will nicely simplify that this is really what? X plus 9 squared, right? It's a perfect square. And so we're trying to kind of navigate this so it gets a perfect square. We're going to use that in just a second. So let's start with the steps of finding the complete the square. So let's go one step at a time. We're going to complete the square. This is a second method. So factoring is one way of solving quadratic. Here's another method. So we're going to learn a number of different methods. This is a method of solving a quadratic. So x squared kind of thing. So here it is. Here's a quadratic. We could probably factor this, but we're not going to. We're going to complete the square. So I guess we could factor it also, but let's just do this. So move the constant over. So this, I want to move that over. In this case, it looks like we're going to have to add 12 to both sides in order to move that constant over. So we get x squared minus 4x plus blank equals 12 plus blank. I'm about to add something to both sides in just a minute, although this second step's interesting. So the leading coefficient has to be 1. Right now, that leading coefficient is 1, right? 1x squared. So I don't have to do this step. If I did have to do something, so if it is not, then you need to divide every term by a, whatever the a value, whatever the leading coefficient is. We call that the a value. We're going to divide every term by, if it was 2x squared, we would divide every term by 2. So you want, for this method to work, you need that leading coefficient to be 1. So you would divide first. So this is kind of the weird step. So think about that, what we just talked about a second ago with this pattern. Like, how do you get from 14 to 49? You took half that number and then squared it to get 49. So here we're going to take half of this number, half of 4 is 2. 2 squared is 4. So you're going to add 4 to both sides here. So you're going to add 4. And that gives you, it should give us a perfect square trinomial. So the way I wrote that is you add half the square of the coefficient of x term, the middle term, to both sides of the equation, which is what we just did. We took 4, we halved it to 2. 2 squared is 4. We added 4 to both sides. What should happen now is on the left, we actually will do some factoring here. And so if you factor that, it shouldn't be too bad. It should be the same factor twice, in fact. So I would just take the square root of that last term, which is 2 there. It looks like that the signs have to both be negative. And so, in fact, allows us to skip that step and then go right to this step. I want to write it in that form. It's going to be the same factor twice. On the right, whatever 12 plus 4 is, it's 16. So now, I guess, so the fourth step there is simplify kind of factor to get the equation into the form we want. This is the form we want. At this point, complete the square is pretty much done. We've got it in the form we want. Now you just have to do your, like you know what to do from here. This is kind of like what I said. If you get this far, you just square both sides. Let's see, plus or minus, right? And you're going to be able to solve from there, hopefully. So this will be x minus 2 equals plus or minus 4. Add 2 to both sides. So we get x equals 2 plus or minus 4, which is 2 different answers. 2 plus 4 is 6, and 2 minus 4 is negative 2. And so, well, let's just try this. So could we have factored this? Well, let's see. X squared minus 4x minus 12 equals 0, right? So if we tried to factor this, let's see if this has been faster. X and x. See, factors 12 to add up to 4. 3 and 4 don't work. 6 and 2 could, I think. Minus 6 plus 2. So x equals 6 and x equals negative 2. That seemed a little faster, a little easier than complete the square method. So you might be going, well, how come you are learning this new method? And I guess the reason might be, if you can, I guess not everything factors, right? So if you had a quadratic like x squared plus 6x plus 1, I can't factor that, right? So I'm stuck. I don't know what to do. Can't factor it. Complete square will work on that. So the nice thing, the advantage of complete the square is it works on every quadratic. You can complete the square on every quadratic. It gets a little messy sometimes. The fractions are tough, but it works on everything. Factoring is fast, it's efficient, but it only works on some of the problems. So if I had a choice, I'd try factoring first, but if it doesn't factor, complete the square is an okay method to solve it another way. So this one, I don't know if that factors. I don't think it does, in fact. So I'm pretty sure this one doesn't factor. So so we're going to use complete the square because right now it's the only other method we know that could work here. And this is a little tougher example, so I wanted to show you a tougher example. First step is the same. You're going to move that over, so you get 2x squared plus 6x equals 5. I guess I didn't show my work, but you added 5 to both sides. Second step is the leading coefficient has to be 1. Right now it's not, so I'm going to divide by 2. Divide every term by 2. That first leading coefficient now is 1, x squared plus 3x. I'm going to leave room for what I'm going to add to each side, and this is going to be 5 halves plus blank. Okay, so now we're going to take half of this middle term. So half of 3, I know it's 1.5, but I prefer to write it this way, so I'm going to write it as 3 over 2. So half of 3 is 3 over 2. 3 divided by 2. That's half of it. We're going to square that value, so it's easier to do as a fraction. So square that and you get 9/4. So I'm going to add 9/4 to both sides. And now let's see what happens here. So this should be a perfect square, should be able to factor. In fact, I'm not going to spend a lot of time factoring this because I know it's a perfect square, plus and plus, I know it's plus. I always just take the square root of the last term there. Square root of 9/4 is 3 halves. I factored it. Or you take half of that middle term, because it's the same kind of factor every time. Half of 3 is 3 halves, and you got it. I do have to add these two fractions up, so you might have to do some work here. I would probably multiply this by 2 over 2 here, so that we can add those two fractions up. So we get 10/4 plus 9/4 is 19. Wow, 19/4. I told you it gets a little messy with the fractions, right? Okay, so now we're going to take the square root of both sides, right? So we're going to take the square root of this side, take the square root of this side. Don't forget plus or minus. And let's see what happens here. So we get x plus 3 halves, that's not too bad, equals, take the square root of that. So it'd be plus or minus square root of 19 in the numerator. And I'm going to go ahead and simplify the denominator. Square root of 4 is really just 2, so it's square root of 19 over 2. Okay, last step is subtract 3 halves from both sides. And so you get x equals negative 3 halves plus or minus square root of 19 over 2. In fact, you can write it like that. That is perfectly acceptable answer. I'll take that. Some students really like to kind of like just simplify just a little bit more, and they'll add that up as one fraction. And so that also is acceptable answer. Both are just fine for me. So either way you want to write it. They will. One thing that's nice with this method is the fractions usually add up really nicely there at the end. So you can just put that all together there. It's actually pretty nice to do that. Try one more because again, this is kind of on the tougher side of things. Let's, especially when this is odd, it's just a little bit of work. So let's move the 3 over first. We get x squared plus 5x plus blank equals 3 plus blank. You're going to add half that middle term. So half of 5 is 5 halves. You're going to square it. So that's going to be 25 over 4. So I'm going to add 25 fourths to both sides. And the left-hand side should simplify nicely. It's plus and plus, so it's got to be plus. Square root of 25 fourths is 5 halves. And to add this, I think I'll need to have the same fraction. So this would be 4 over 4, 12 over 4. 12 over 4 plus 25 over 4 is 37 over 4. Square root both sides. You get x plus 5 halves equals plus or minus square root of 37 again, divide by square root of 4, which is 2. Subtract 5 halves, so x equals negative 5 halves, plus or minus square root of 37 over 2. Or you could write that as one big fraction, negative 5 plus or minus square root of 37 over 2. So that's not something we could have factored to get that answer, right? If it was a nice rational answer, you think, well, I probably could have factored it, but here it has a square root in there. I don't think we're quite capable of factoring that. So this is a very flexible method to use in that way.